Broadcast is now starting. All attendees are in listen-only mode.
Hey guys, thank you for joining us today. I can see that there are a few people here already. We'll give it a few more minutes and we'll get started just after 1 o'clock on the dot. Afternoon, everyone. I can see we have a few more people that have joined. We'll give it a couple more minutes and we'll probably start at about 1 minute past the hour just to let any latecomers join in due course. Okay, I think we will get started. It's 1 minute past. I'm sure there'll be more people filtering in as time goes on. So welcome to this installment of our Civil Community Meetup. So my name's Adam Walmsley, if we haven't met before, and we're joined today by Chris and Elan from Innovyze. So Innovyze is a water infrastructure company, software company that Autodesk acquired earlier this year. So those two are going to do the bulk of this presentation today. I'll talk for probably the first 5 minutes or so. So a bit of an agenda. Yeah, I'm going to give a bit of a community update as I usually do, talk about things that are coming up and things that I'm hearing from my conversations with other people around the industry. Yeah, then Chris and Eland will jump into it, and we'll have a Q&A. So if you want to ask any questions at any time, type them into the Q&A box or the question box on your screen there, or save them to the end, and we'll get to answering those towards the end of the session. So a bit of news around Autodesk University. So I think most people will know that that's our annual event that we have. Unfortunately, we won't be in Vegas this time for obvious reasons, but we do have a virtual event. It's going to be free to all attendees, and it's catered for time zones around the world. So we have an APAC time slot, which is running from October 7 to 8. And yeah, you can jump online. Easiest way to get there is to Google it like I have here, and you can register, and then I think the classes will be online soon for you to start to look at. Some conversations around software that I've been having with a lot of people, and I'm getting a lot of interest around this, is a tool called grading optimization for Civil 3D. Now, this is a new tool that sits inside of Civil 3D. It was released this year. What it does in a nutshell is helps automate the grading process of tin surfaces around a site. So, and I've got a good example on the left in this video is grading around a bridge abutment, which I know can be a really time-consuming process if you try to do that stuff manually. And then on the left, you've got grading sites based on drainage parameters and different site constraints, such as the road alignments and things like that. So this is inside of Civil 3D 2022. It's there to be played with, I guess. If anyone wants to know a little bit more about it, feel free to reach out to me and we can have a chat. And the last little update I'll talk about, which I think is worth addressing, is last week or maybe the week before, Infrastructure Australia launched what they call their infrastructure plan for 2021. It's a really comprehensive document, but section 3 is really interesting for this audience. It's really focused on productivity and innovation in our industry. And then there is a subsection in there which is called digital by default, which is a really interesting a piece of information to read. Now, what's really nice to see is that the government has released this document, and then it does talk about all of the favorite tools and technology that we use, such as building information modeling and big data and prefab and modular construction and things like that. So it's really good to see that these recommendations are coming to light, and it really justifies the importance of us getting together like we are today to talk about technology and innovation, and how we can start to apply all of that to the projects that we work on. So with that, that's a bit of a good segue, I think, to hand over to Chris and Elan from Innovyze, where they're going to be talking about innovative software and how it can be applied in the water space. So guys, welcome. Let me change presenter and I will hand it over to Elan. Okay. You got that?
Yep, thanks, Adam.
We can see your screen too.
Thank you.
No worries.
All right, thanks, Adam. Hello, everybody. My name is Chris Ryan. I'm a regional sales manager for Innovyze here in Australia. With me, I have Eland Aquang, who is not only one of our key solutions engineers, he's actually the team leader of the entire group here in Australia. And today we'd like to just go through a little bit of an overview about what's been going on, a bit of an agenda, which we'll get to shortly, and give you a bit of an introduction to Innovyze for those that don't know us. So, Elan, could you move to the next slide, please? So some of you may or may not know, earlier this year, Autodesk, as part of their global strategy, acquired our organisation, Innovyze. Basically, we have been in the water industry supplying engineering modelling software for the water industry specifically for about 35 years plus, and recognised globally as the industry leader. And as part of the ongoing development commitment to the civil industry, Autodesk basically saw the capabilities that Innovyze could provide. We have a long-standing relationship with Autodesk, with some ability for some of our products to be have results exported into Autodesk products, and opportunity to bring the water industry and the civil engineering area together. We'll touch on in a little while, but also we augment the BIM offerings that Autodesk provide, and also moving through into digital twins, which we'll touch on in the future. And what we're going to do is just walk you through some of the technologies that we have, which will help with the civil design projects and help meet requirements for utilities and councils and regional water authorities across the country. Onto the agenda, basically, what we're going to address, the difference in using Innovyze compared to other products in the market, what our portfolio actually looks like, and how hydraulics and hydrology, looking specifically at stormwater, drainage, flooding, and water and sewer, can assist in your designs and moving forward with your clients. Also, we're going to address digital twins as well, just as a bit of a roadmap for the technologies that we provide, the things that our marketplace and water utilities and large councils are asking in that digital twin space, and just give you a high-level overview of how that can all work together. So on to Innovyze. For those that don't know us, basically we're water professionals, engineers, software development people, and the global leader in having infrastructure data analytics for the water industry. So being able to provide Innovi Solutions, help make decision making, and basically give evidence-based engineering results for where civil infrastructure needs to go. We're quite a large organisation before we got bought by Autodesk, and subsequently added another 13,000 close friends when that happened. But basically, around the world, as you can see there, there's some big numbers. Basically, top cities, top water utilities around the globe use our technology to manage their environments, to manage what their deliverables to the clients and their customers are, and with lots of different licenses, heaps and heaps of clients all the way around the world with lots of experiences, put us in the forefront of people's minds with regards to water industry engineering. Our locations for Innovyze ourselves, we have head offices in Portland, which lines up with where the AEC team with regards to Autodesk are. We're also in Canada. We've got development teams in California, Colorado, and also in the UK. And here, the Australian head office is in Brisbane. We have staff all along the eastern seaboard, and we cover clients all the way around Australia, and we support our channel partners up through Asia Pac and in New Zealand as well. Basically, nearly half of our staff are in R&D and development, so we're very keen on making sure that our products meet the marketplace and are very innovative. Moving on. So what we're going to focus on, and the areas that we're focusing on, is obviously we've got water distribution and management, stormwater, sewer and flood modelling. We'll touch on that a little bit deeper today. Just as a bit of a byline, also the largest flood study in the world is being done in Innovise software at the moment, and that's down in Tasmania, where there's a flood model being built for the entire state to do preparedness for flooding and being able to manage risk associated with human life, etc. down there as well. We've got specific asset management technologies that align with the models and align with other asset software that is in place, looking at condition assessments and being able to categorize where things need to be replaced or where things can need to be fixed. We've got drainage design analysis software, and we've also got our operational analytics where we can do incident management, we can do simulations of incidents, customer impact, and also in the treatment plants for water and sewer, we've also got our AI machine learning technology, which helps optimize the use of power and chemical to be more environmentally sustainable and also reduce costs associated with running those operations. Next slide, please. So I just passed across to Elin. He's going to walk through now basically the areas of the difference in using Innovyze over other technologies in the marketplace, and then jump into having a look at some of the products. Elin.
Thank you, Chris. Hello, everyone. My name is Elan, and I'm a solutions engineer, lead for Innovi Solutions. So just to walk you through in terms of the differences in using our applications compared to other platforms, I'm going to as well provide like some demonstration of our particularly couple of core modeling platforms. But yeah, for now we'll cover the differences. So here is several of the differences that we offer in terms of the advantages in the market. So being aligned with many policies. So our solutions are preferred by majority of councils and utilities. So particularly in Australia and New Zealand. So like that graphic covered by Chris, we covered 100% of the major cities in the country. And what we would like to I guess emphasize in terms of the difference in using Innovyze is I assume that majority of the audience here are doing civil design work. We definitely can complement in terms of like what you guys do, but at the same time we cover quite a long, like literally a long period of engineering, from utility planning, asset management, and operations. So pretty much once the asset is built, we essentially cover the whole life cycle of the asset. And I'm going to provide some examples and information on that. Second major point about the difference, simplified versus best practice modeling. So we do best practice modeling. So the tools built in our applications follow best practice workflows, and this is 30-40 years of like development, working with utilities and councils around the world. So you might be familiar with some of the terminology here, but I will try to explain in a bit of a general term. So many for example designers or modelers, they will think about when they start with their analysis to do a rational base analysis or modeling, whereas in our application we typically do event based. So like the Australian rainfall and runoff 2016, the latest AR&R, it's built into our application, so you can literally generate, for example, your ensemble storms using the application, using Innovyze application. steady state versus dynamic. So steady state is typically, more of like an instantaneous design, for example, peak hour or, peak day. But in majority of our platforms, you do dynamic modeling. It's inherent into our application. So it's not just looking at one specific point in time, but, pretty much best practice. So for example, for water distribution, we cover, at least a 24-hour period. For a sewer design, we cover typically, your dry weather and your wet weather time when we're doing sewage analysis or modeling. And then the last example is we don't simplify, the modeling. So this is more of for built-in infrastructure, right? So I guess like 20 years ago, maybe, or even 15 years ago, some people will have this idea that, we need to skeletonize, for example, your water network or your sewer network, your storm network, because, it will be quicker to run the analysis. But in reality, technology has been able to catch up. And our core modeling platforms, inherently they do all mains, all pipes modeling, explicit hydraulic analysis. So those are several of the differentiation between simplified and best practice. And then going to my third point here. So what's the ramification of having a simplified approach? And I'm sure you guys would have some ideas. A simplified approach tend to leads to over design, which means more work or rework. And the good news is, since we are now combined with Autodesk, we can significantly improve your workflows, be able to complement, not just your design work, but as well as, if you will go into more of the utility planning and asset management and operations space, definitely our solution would be able to offer that. Several examples here, in terms of alignment with the planning and design guidelines. So I took, a snippet of this preferred design program for this particular council. So these are, Innovyze applications. The big four in Victoria or greater, Melbourne, I should say. So, Melbourne Water, Yarra Valley Water, City West, now Greater Western Water, Southeast Water. They build a specification, model build and calibration around Innovyze application. The one in the middle from the Queensland Government, Department of Energy and Water Supply. So planning guidelines for water supply and sewerage. It's pretty much, aligned in terms of the way they design and manage, water and sewer assets. And then across the Tasman, we have a Water New Zealand modeling group, which is part of the Water New Zealand. They essentially the governing body, providing guidelines for all the councils and utilities in New Zealand. So essentially they built their spec as well around Innovyze application. In terms of a specific use case, you might ask, so this is a real example I took from an inquiry from a consultant, storm, design, stormwater practitioner essentially, wherein, the council raised, some concerns or issues in terms of like simplifying the design work. So yeah, unfortunately, there are several here, and you guys can see that majority, is essentially not considering, other factors, for example, or simplifying, the design methodology. So these issues or concerns, the good news is that, these shortcuts, I'd say, can be addressed by inherently using Innovyze tools. So yeah, this is an example of a specific development application that you could use. For example, our solution to deliver a more complete best practice, and obviously approved based on the policies when you're doing your design. So this, you guys might ask, how do we integrate with Autodesk? So this is just a schematic, or like, not schematic, but more of like a diagram in terms of where our products sit. And we have here, different disciplines like water resources, stormwater, flooding, water distribution, sewer, and then your water, wastewater, industrial. And I imagine most of you are familiar with the Autodesk tools. Innovyze tools are, those green colored, platforms or logos. So what I'm going to demonstrate at this time is our two core modeling platforms called Innovyze ICM and Innovyze WS Pro. So Innovyze is a modeling platform that can do sewer, storm, flood, as well as a water distribution. And I would be providing an overview demonstration of these two platforms. So just to start with Innovyze ICM. So ICM stands for Integrated Catchment Model. So this is a software, a single solution with fully integrated river, urban drainage, and overland flow modeling. So it's one of the few that can do, I'd say like true 1D plus 2D, hydrology and hydraulic integration. There are not many in the market. The third capability there is very unique with Innovyze, with Innovyze. So we have developed a robust, we call it a work group backend, wherein you have a master model that can sit, for example, in a centralized server, and then multiple people can access it and work on it simultaneously. A lot of modeling platforms in the market, they are using a file-based system, and it's not suited for collaborative work. And then we also future-proof this platform, because we have worked and understood the market for a long time. So it also future-proof in terms of being able to go into the operational live modeling space. Let me just go through some of the features in the software, and then I'll do the same with the other platform. So this one is Innovyze ICM being able to realistically model a surface flooding. I mentioned the dynamic coupling of 1D and 2D. The terrain sensitive meshing is quite unique in our hydraulic engine. So for example, with other applications, they use a grid instead of like irregular mesh. So ICM use irregular mesh or triangles, and then there is a terrain sensitive meshing wherein the software can optimize the resolution of the triangles within the mesh. So you would be able to refine, for example, change in elevations, and be able to more accurately model your terrain using the application. So you can accurately represent buildings, curbs, inlets, others. The other powerful tool in the software is to be able to use GPU. So literally, the technology that you can use with video games, right? So to be able to simulate the calculation faster. So this is not unique with ICM, but it complements the terrain sensitive meshing, as well as to be able to do distributed computing. The application can also quantify flood damage and at properties, level. And, I mentioned about 1D and 2D. It can also do water quality across, the whole domain. The other advantage is to do like, advanced water quality. So I know some of the modeling platforms, as well as some, civil design, a software that does a bit of modeling can do water quality, but most of them are like, the basic and quite simplified. So this is, again, more for a utility planning and like, built infrastructure. So once you have your infrastructure already laid out, and you're trying to manage, all these water quality concerns or parameters, you would be able to accurately model these parameters into ICM. And then I mentioned about this might not be familiar with some of you. So in terms of the ability to do advanced real-time controls. So since we are modeling actual operations of the asset, we need to mimic, real-time controls. So this one is quite a complex example, when you could see on the right, a complex treatment plant system, and the real-time controls, listed on the right. So there's so many complex logic that runs every asset, and ICM can handle all those complexities. It's able to integrate pressure and gravity system interaction seamlessly, as well as to be able to connect directly to SCADA, or any time series data. And then lastly, for InfoWorks ICM, I mentioned that we future-proof the application. And so there is a module wherein you could run, an operator-based application of ICM called ICM Live. So the idea here is to be able to connect to your SCADA or time series data. So, the application can, automatically, for example, model the changes in like, pump operation or like, valve operation in real time. And then, for this specific example, you could also integrate, for example, rainfall information in real time. So we have integrated with, a lot of weather bureau data format, where we could ingest, real time weather rainfall information, and essentially inject that into the model and see, what will happen in the system for the next, 6 hours, or if there's a big storm event. We have a use case, for example, in Belgium, wherein literally there is a web-based application developed by the bureau, wherein ICM is the hydrology and hydraulic engine running in the background, and people can literally click on their house, on their property, and see the predicted flood depth. If there's an incoming or like a predicted storm happening for the next 6 hours or a day. So that's some really advanced applications that's used all over the world. And then InfoWorks WS Pro is the counterpart of ICM, but for water distribution, water supply. All of the features that I'm going to cover here, again, it's not specifically for design, but more for like, operating the system, and as well as managing, the assets in real time. So similarly with InfoWorks ICM, this particular module can accurately and realistically model water distribution assets. There's this work group functionality that you can collaborate, with your team members, and again, it supports operational modeling. So this one here is, just showing how the application can mimic asset operations. which might not be relevant, like, for the preliminary design, but like, once, the network is built, like you're managing it, it's definitely relevant. So in here, it's just showing, a particular a water hydrant, wherein you could explicitly model, the operation of the hydrant. Real world modeling of pumps and valves, operations. So, in this one, it's showing the essentially a variable speed pump. So a lot of pump design, it's essentially using the a nominal point, or the duty head and the duty flow, but the application can design as well as mimic, for example, variable speed drive, wherein you have a minimum, a maximum, and then your nominal speed curve, and you could see literally the operation of the pump hovering in between the minimum, the maximum speed. So why do we need to have this type of feature in the application? This is essentially to enable accurate operation design of the key assets, as well as increase confidence in the model over time. And then this other one, again, has something to do with once the assets are built and in the ground. Typically, when you're doing design, it's more of like looking into, for example, your average day or your peak hour or your peak day. But once it's built, once it's being operated in the field, the software has the capability to do realistic demand modeling. So all of the applications, I'm confident to say that all other applications model, the blue graph, line there in the graphic. So, that's like, when you're trying to model, for example, a pipe burst and you're closing a valve. So most platforms, when you shut up a valve, there will be a instantaneous, cut of supply. But you can imagine that it's not the case in reality. So the application Innovyze WS Pro does do a better job in representing, accurate, hydraulics and demand response, where it, model the gradual loss of supply and pressure based on, the demands and the pressure in the network, as well as, being able to recharge it gradually. And it's customer centric, wherein you could model individual customer connections. So a lot of modeling platforms in the market, they are using a simplified method wherein they are representing the customer connections in more of like a pseudo GIS based connection. So again, it's useful for increasing model confidence, as well as helping operations effectively manage the system. And then lastly, for Innovyze WS Pro, I mentioned that it's similar to ICM, wherein you could move from design through to planning, through to operations, live modeling. So this one is an operator-based module of Innovyze WS Pro, wherein you have a live model, similar, with, for example, your sewer or storm system. This water supply network is connected to SCADA, or time series data in real time, to essentially, drive initial boundary conditions, tank levels, valve status, pump status, as well as, there is a machine learning algorithm that forecasts the demands, for the next, 3 days, for example. And you could do what if scenarios, modeling, to see the impact of, for example, isolating a pipe burst, or if you lay, for example, another pipe across, for example, this section of the system, what will be the effect, in the system. So again, to be able to trust in making decisions, when you work in a utility or the council, as well as to build confidence in operations. So those are just some quick, demo overview of some of our platforms. I'm going to pass over to Chris to talk about, how we connect with or we build upon digital twin.
Thanks, Elan. That was a good overview, mate. So some of you may or may not be aware of a group called SWAN. SWAN is the Smart Water Networks Forum. It's a global association that's been put in place to assist water utilities globally with regards to digitization and moving towards a digital utility. And they've come up with this architecture mid last year about how you can move from managing a physical system to having a digital twin of the system. Now, I know it may not be applicable to a lot of you, but your customers are asking us about this. So if you have a look at the digital twin on the right-hand side, Elan, if you could just press the next, there's little red boxes that are going around the different areas here. So data integration, analytics, visualization, user experience, being able to run, ingest and integrate data together, to manage it, to do both physics and data-driven models, to do simulations, which is what you saw with Elan walking through before at a high level, and all the what-if scenarios and performance dashboarding and things like that. Parts of that are already available in Innovize's product suite to be able to do this. So Innovyze has been working for a lot of years. I think our first digital twin that we did, I think, was about 14 years ago. And it's obviously been growing and growing ever since that point. So move to the next slide, please. So if you have a look at the bottom of this little roadmap, basically the commercial aspects of what customers are looking for. Is it a project-based budget? Is it a portfolio management budget, i.e. O&M? Is it coming out of CapEx? Is it coming out of OpEx? What's the total cost of ownership over that whole period? Is one focus that people look at. And then the next one that they look at is the time horizons. Is a project-dependent horizon. The planning team are looking at what happened 5 years ago to today and what's going to happen in 20 years. The operational guys are looking at forecasts from what happened last week to what's happening next week. And the guys that are running the plants and the operations are looking at what's happening now and what's going to potentially happen in the next 24 hours. And then based around all of that, we have the design and construct aspect, so discrete engineering, which is where our friends at Autodesk come into it. And then across all of those planning, operational scenarios and live operations, you've got water networks, sewer networks, storm and flood planning, coordinators, live operations, and now, which is growing exponentially across the country, is looking at recycled water opportunities as well. Then based upon all of those things, you've also got to bring in what's happening in maintenance, what's happening out of the work orders, what are the field observations, what are the conditions assessments that are going along with the capacity that's being done underneath there in the different planning departments and operational environments. And to get all of this stuff to work together, you need to be able to aggregate the data together. And it's not just the data out of the systems from Innovyze, it's also what's happening out of SCADA, what's happening out of your GIS, what's happening out of the ERP and the CRM system. Your condition assessment might be saying X associated with a piece of pipe, and you might look at it and go, we could probably replace it in the next 18 months. But the 65 complaints out of the CRM system that says that there's a leak going on there means it needs to actually be done something about it now. So putting all those things together and being able to put it on a visual platform and being able to see all of this information put together on it in some form of a viewer means that you can have little mini digital twins across each of the water, sewer and storm and flood, plus the capacity and condition be addressed and have that visualized in front of you. So this is the roadmap that has been put in place that is based, most of the water utilities and large councils are actually looking at to start building digital twins in their environment. And from the civil side of things with regards to storm and flood planning and drainage planning, and those of you that are just working on designs with regards to sewer or water network expansion, it's going to be very valuable in how you put all those things together, because the councils are going to, and the utilities are going to be putting all of that information into these twins to be able to run it through the future. You go to the next slide, please. And all of those little red boxes, once again, are areas that we can consider. So if we go back to this swim lane drawing infographic that's on that Elan showed before on screen, we're talking about what's happening in the structures and the networks of the treatment plants. then the way it's laid out is it's almost like a 25, 25, 25, 25, you know, a quarter, 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 quarter type of space. In real terms, with regards to the cost of the assets, of some of you may be aware, is the operate and maintain end of the life cycle of an asset is the most expensive. And how do you support that ongoing from a planning and design phase? And that is where our tools, the InfoWorks ICM and all the Autodesk tools that are coming in place, being able to plan the environment and know and do forecasting and scenario testing prior to putting a shovel in the ground with a solid design is going to make that O&M much easier for the owner at the end of the day. And the way that Innovyze does it is that we actually plug our front end with the ICM and WS Pro and those tools in the front for planning and design through to our tools at the back end that do the digital twins, such as Info360, Imagine, and Info Asset. So being able to connect the front to the back is a very big, important part of being able to do planning and design prior to construct to make O&M a lot easier. And that's the main focus of Innovize's business. And it's one of the key reasons that Autodesk actually acquired Innovyze, to be able to go from planning to O&M, asset disposal and renewal process, and go around for that whole asset life cycle. So I hope that that information that we presented to you today is of some value for you and gives you a little bit of an insight into our organization, some of the technologies. There's a lot more that we could go on to, but in a short session, we just wanted to touch on what it would, the key things associated for you know, flood, sewer and drainage modelling, and also what's happening out there with the utilities and councils that you may be working with that are running water authorities on the aspects associated with what they do for the networks and how that all ties into the future of digital twins. So with that, I'd like to say thank you very much. And if you have any questions, please pop them in the question box as we go. And Adam, thanks very much.
Thanks, guys. That was really interesting. I'm not a water person, so I've got a couple. Can I ask a question?
Yes, of course.
I hope it doesn't seem a bit simple, but in Eland, in one of your first slides, you had a statement there about a simplified approach leads to over-design and more rework. Are you able to give me an example of what that means?
Oh, yeah, sure. So, yeah, if I go back to that slide in particular.
I hope that's not a really basic question for all of the water.
Yeah, no, it's, yeah, it could be simple, it could be not, but yeah, based on my experience, since I've worked in the industry for quite some time, is that the way, for example, you size the pipes, they are based on, like, you know, simplified method. So I mentioned here, like, rational versus event-based. So this is quite common with, you know, storm and sewer, you know, design, as well as water distribution. So for example, when you size a pipe, you would only use, you know, for example, a direct equation, like a single equation, or maybe, you know, some factors, right? You essentially just try to convert, for example, the design flows into a capacity of your pipe, and then, like, you know, apply like, you know, a factor to essentially give you more you know, leeway, right, in terms of, like, designing your system. But in reality, it's not as simple as that. So when you are modeling it using, for example, InfoWorks, you base it on typically practitioners will, if possible, will acquire, you know, the model from the utility, for example, if it's available. So, like, you know, the connecting points in the system, and they will try to start from that and model it dynamically, right? If that makes sense. So yeah, so instead of just simplified modeling, which leads to design decisions, it's more of like, not complex, but best practice modeling. I hope that helps.
Yeah, for sure, for sure. Another one, there's a question in the Q&A window. I'll ask that from Ram. He said, could you specify advantages over 12D in terms of features?
Oh, that's a complex question, because 12D is like, a full, as you guys know, it's a full feature civil designer tool. I guess I'll speak on, some specifics, right? I've looked into 12D and I've seen people actually use it. And I mentioned about, the rational versus event-based. So, there's an inbuilt rational methodology in the drainage network feature in 12D, which is fine. And it actually works really well for stormwater design. But like, for stormwater, pipe design, but like for water and sewer, it's not best practice, right? So, for example, with the water distribution methodology, there's a dynamic non-steady state option in the application, but many practitioners I've observed, they will essentially apply, for example, a constant a curve, diurnal curve, to mimic, for example, a consumption, right? Whereas in the other side, where people use, for example, InfoWorks, they will dynamically model it, right? If you're sizing your water pipes, for example, you would dynamically model the flows into the system. So if it's a heavily, residential area, which is a lot of that's like the case most of the time, you would have a diurnal profile wherein you could mimic, the for example, the morning peak and the afternoon peak change in the demands in the system, and then that's your basis of like sizing your pipes instead of just a fixed flow, which you can imagine would lead to over design. So those are a couple of things I can think of. And there's so many other methodology like workflows and InfoWorks that are not available, for example, in 12D. But yeah, that's I guess a lot of those other methodology are used in terms of utility planning and operations and asset management instead of like your preliminary design. So you have to pick and choose like what would be the most appropriate.
I feel like you could probably talk about this all day.
I can.
He can.
I'm freestyling at the moment, but like I can talk.
There's a few more questions that have popped up.
Yeah.
I think I might be able to answer this one, unless Chris or Elin, you know anything more than I do. But what is the plan with the current design tools in Civil 3D, i.e. storm and sanitary analysis and hydrographs that do not work that well? I haven't seen a roadmap for any particular integrations between Autodesk and Innovyze at this point. I'm hoping that that's what the question is pointed at. Chris and Elin, do you know anything different than I do?
No, mate, you're exactly right. Like, obviously, the integration between our two organizations is still very new. I know that there is a myriad of planning sessions that are going on in the back ends of the organization on with the R&D teams and how and where and when and what is going to potentially be put together and talk to each other, etc. That is not decided as yet, and obviously it means that it's not overly public. But Elin, do you have some information with regards to how we currently work with Civil 3D that may help?
Yeah, thanks, Chris. So yeah, there are current there are opportunities to integrate. For example, we directly support the TINs in Civil 3D, actually as well in 12D, because 12D was mentioned. in that previous question. So you could like export your 12D or Civil 3D TINs into ICM, and you could start doing your, for example, 2D modeling, because ICM can ingest TIN model and like build it directly within the application. So it kind of mimics the TIN model, but that's like the foundation of building your 2D overland flow modeling. So you could also, for example, import other Autodesk format like CAD format into Inforix, as well as generate long sections in Inforix, export it to CAD. So yeah, I guess to answer the question, there are several features that integrate cross platforms. But in terms of being like the long term, it's being discussed. It's quite complex topic.
Yeah, it's a watch this space in situation, really. And I'm sure as and when developments and whatnot happen, both your Autodesk representatives and ourselves will have some more information that we can share when the time is right. But it's one of the key aspects of the purchase of Innovyze by Autodesk is in this kind of space. It's with regards to our asset tools, it's about our digital twin tools for operational aspects of networks. It's about how our hydraulic modeling technologies help support products like Civil 3D and InfraWorks. So there's a lot to happen, but it's very exciting times.
There's another question here. This is this sounds like a technical question. So, can this modeling substitute ARI of particular area collections in the future?
Yeah, I'll try to answer that, Adam, Chris. So yeah, to those who are not familiar, ARI is average recurrence interval. So it's a terminology essentially to, it's also called return period or AEP. There are many terminologies, but it's like the average number of years that it's predicted before a given event. So yeah, to answer a question, particularly like storm event, to answer the question, it's not a substitute, but it complements, because like I mentioned in Inforix ICM, you could there's a built-in tool wherein you could use the Australian rainfall and runoff, ensemble storm modeling, right? So directly, in the application. So ARI or ARIES is a simplified version of that, which is interesting because that's exactly what the slide that I'm showing before. Yeah, so it's to answer the question, it's not a substitute, but like it's there's a best practice counterpart. You could also do ARI modeling in ICM, but you could do more of like best practice version of that.
Okay, thanks. I hope that answers his question. Just conscious of time as well. We've got another one here. I think I can answer this maybe. Currently, there is a compatibility issue for importing 12D models into Civil 3D, especially drainage. Can we expect to overcome this in the future due to Innovize's integration with Autodesk? I would say yes. Hopefully that is the case. Once we integrate a bit closer with Innovyze, there'll be a better shift of information from Innovyze products to Autodesk products such as Civil 3D and others. Do you guys have any comments on that?
No, it sort of goes along the lines of the previous one. Obviously, as the integration happens, and there's I envisage hopefully at some stage that there's a click this button to export it to Civil 3D or something like that. That's very simple. It just passes it across. Who knows? That's my wish list, obviously, because if we make it as easy as possible, then it's going to make life a lot easier for everyone to use. But that's all still in design and working those bits out. But the high speed hydraulic engines that we have and its extreme level of accuracy is one thing that would pretty much launch Civil 3D into the next level, and pretty much leave most of its competitors in its wake once that's all built in and put together. So it's just a watch this space kind of thing, really. But the whole idea is to make our products, where applicable, interface into Autodesk's environment where applicable, in the best possible way over some period of time yet to be determined.
Okay, so there doesn't seem to be any more questions. Maybe we should wrap this up now. So I guess if anyone wants to reach out to us, you can grab us on LinkedIn, or if you've got our email addresses, feel free to email us and we can continue these conversations. But yeah, look, I'll just want to thank everyone for attending today. I hope you found this a valuable session. I certainly did. And yeah, thanks to Chris and Eland for dedicating some time today. And yeah, we'll wrap it up now.
I appreciate that, Adam, and thanks everybody.
Thank you, everyone.
Have a good afternoon.